So, good afternoon, everybody. We'll be talking about an assessment prep for some of my 2Ds. And today we're going to be talking about, it says here that how long would it take for an investment of $3,200 to grow in value to $7,000 if the investment is earning 6.2% interest compounded quarterly? And we must write an exponential model and use it to solve the problem. And some hints it gives us, it's earning 6.2% interest compounded quarterly. So there will be 4 quarters. And the 6.2%, if we move it to decimal form, it'll be 0.062. So I think with this information we should get started. So it'll be the model will be y equals 3,200, 1 plus 0.062 over 4, because it says quarters and there are 4 quarters in a year, times 4x. And next part is that it wants us to figure out when the value will be 7,000. So y will be 7,000. So 7,000 is equal to 3,200. And if we plug this into the calculator, we do 0.062 divided by 4, we get 0.0155. If we add this with 1, we get 1.0155. So we're going to write that 1.0155 to the 4x. So what is the next step? Well, the next step is to divide 3,200 to 3,200. And if we do that, we will get 7,000 divided by 3,200 is equal to 1.0155 for x. Now, what is the next step, you may ask? Well, we have to multiply by a logarithm on both sides of the equation. And after this, what we will get is the logarithm statement, which will be logarithm of, I think we could simplify this. We could simplify it to 7,000 over 3,200 we can divide to, because we can divide by 100 on both sides, it would be 70 over 32 equals 1.0155. And let me move this real quick. And we're going to move it a little bit. So we're going to shift it over there. And we're going to write log of this times 4x. So what's the next step then? Well, the next step is to divide this logarithm, this log of 1.055, to this side, the logarithm of 1.0155. And that's what we're gonna do. And let me erase all this because I just explained it to you guys. And we're going to do, so it's going to be logarithm of 70 over 32 over the logarithm of 1.0155 is equal to 4x. So let's just solve this logarithm and see what we get. Now on your calculators, I'm hoping this might be the calculator you use in school, but it's pretty similar to the TI-83 Plus or TI-84 Plus, TI-84 Plus CE. So on your calculator, you will see a log button. Press log, put 70 over 32. We click enter, we get this number, divided by the logarithm of 1.0155. What we get is 50.89. Well, we get this big number, but we can use 50.89. So I'm going to move everything, I'm going to shift everything like this. We get 4x is equal to 50.89. Fix this 9. And what do we do next? Well, we just divide by, then we just divide by 4 on both sides. So that's what we're going to do, and we get x is equal to, well, we're just going to put it on the calculator, divide by 4. We get 12.7274472, but we can just keep the two numbers, the hundreds place, and we're going to get 12.72. And that is our answer to the exponential equation. When will it take? How long will it take? It'll take this many times, 12.782. So in this model, we're going to be doing half-life, which is a pain medicine has a half-life of 6.4 hours. If you take a 270 milligram dose of the medicine, and what we want to know is how long until 30 milligrams remain in your body. And we're going to create the model. Let me show you. It's base, the starting amount, b, to the e, to the rate of x, which is time, equals y. So let us get started then. So what we have to do, we don't have a model to show us. We have to create a model. And what we have 270 milligrams, and we have 6.4 equal, and that's our half-life. So 270 times e, and 6.4 is our time to the rate, equals half-life, so it'll be 135. And what do we have to do? We have to solve for r. So that's what we're going to do. If we divide 270 by both sides, we will be starting to get there. We're going to get 135 over 270. But if you plug this in a calculator, you'll get 0.5 equals e to the 6.4 r. And if you don't believe me about the 135 thing, let's just check, because it'll save us more space on our paper. Divided by 270, and we get 0.5. So that's why I did it. And now this is where, sorry for that microphone tap, but this is where our game of not logarithms, we're going to be using a natural log. And natural log is pretty similar to it, but the only thing, it just has ln, and it just has the word ln. So it'll be times ln on this side and times ln on this side. But the thing about natural logs with the letter e is that they cancel out, so these two cancel out. And what we get is ln to the 0.5 equals 6.4r. And what we can do for this is, let me fix that r. And what we can do for this is that we can divide. Let me make a copy of this. Oh. And what we can do here is we can divide by 6.4 on both sides. And this is what we will get. We will get, let me just move around the variables. R equals ln to the 0.5 over 6.4. And let's do this on our calculator. So on the calculator, you will see you have this little ln button. So we're going to press it. And we press 0.5, and what we get, this number, whoa, big decimals. We divide by 6.4, and we get negative 0.10830447. We're going to use the first 4 digits of it. So we have in the final rate our r value, which would be r equals the rate at which it's decreasing the half-life, negative 0.1083. And that's what we're going to use. And in our model, our whole model for this would be 270 times e to the rate, which is this. This is our rate. This is not our answer, but this is our model, which will be negative 0.1083 x equals y. And this is our model, so let's keep this in mind. And the main question is that how long until just 30 milligrams remain in your body. So let us solve this. So we're gonna put 270 times e to the negative 0.1083x is equal to 30 milligrams. 30. So what we can do is that we can divide by 270 on both sides. And let's see if it does look pretty if we divide on both sides into a small decimal, but I really highly doubt that if I remember. And we get 1.1, we get 0.1111, and we're not going to do that. So we're going to have e to the negative 0.1083x is equal to 30 over 270. And we're going to use natural logs again, natural logarithms. And let's move down here, a little bit down, and we're going to multiply by ln on both sides. And if you remember what we talked about, logarithms with e, natural logs with e, they cancel out. So these two cancel out. And this one stays together. So we get negative 0.1083x is equal to ln 30 over 270. So what we get on the calculator, well, let's make a copy of this again. Now what would happen is that after this, what do we have to do? Well, solve for x. So we get negative 0.1083 over negative 0.1083, and we will get x is equal to ln, let's change colors, we get x is equal to ln of 30 over 270 over negative 0.1083. And what we get on the calculator, let's do the math. Now on your calculator, like I said, you go to the ln button, you press it, ln 30 over 270, and we get this number, but remember we have to divide the negative 0.1083, so we get divided by negative 0.1083, and what we get is 20.288, but we're going to round this up. We're going to get x is equal to 20.89, and that is our answer. And I rounded it up, so that's why. So our half-life will be this solution. It will be that many hours, if I remember correctly. It'll be that many hours. It'll be in 20.89 hours, we should reach the milligram dosage of 30. So I hope this helped. And yeah.